Mr. wears 5 different pairs of socks to last the week, and they are scattered loose in his drawer. That's exactly what I do, actually. Each morning, he gets up before light and chooses 2 socks at random. Find the probability that he wears a matching pair, and then there's a whole bunch of sub-questions. Okay. So, yeah, I don't know if they've been smiling on me or something, but this is exactly what I do. I don't know, I think I have more than 10 socks, but same principle, right? So let's unpack this. Let's start with the first one, because it's the easiest, okay? Each morning he gets up before light and chooses 2 socks at random. Find the probability that he wears a matching pair the first morning. Okay. So I'm going to write this as probability. I've got a whole bunch of different ones, so I want to describe this in a nice, succinct, but unique way. Of a matching pair, a match on the first morning. This is what I'm interested in. Okay. Now let's think about this. You've got to be careful about it. I have to pick 2 socks, right? I've got to pick 2 socks. So this is a multi-stage event, if you want to think about it that way, right? I've got to pick the first sock, and then I've got to pick the second sock. Does that make sense? Okay. Now, let's think about that first sock. And I'm just going to write out over here. I don't have 5 colors, so I'm going to write them just as different letters. So here are my 10 socks, 5 pairs, right? 5 different colors, letters, you get the idea. Now think about that first sock. Does it matter which sock I pick? Like, do I want a particular sock over any other one? No, it doesn't matter, right? So the way I can think about this is, being that this is all about probability, right? Probability, and probability is a fraction. Probability is always a fraction of something over something. What are the 2 things? It's favorable outcomes, right? Favorable outcomes, the ones that you want, over sample space, right? Okay? So being that, my sample space, clearly that's 10, right? But when I asked you, like, which sock do I want? Well, we don't care which one. They're all good at this point in time, right? So the favorable outcomes is 10, right? So the first thing I'm going to write is 1. Now you might think, well, why are you writing that? That's not going to change the answer. No, it's not, but it's meaningful, right? As you will see, capturing all our meaning in the working out that we do is critical. It starts off easy, but it gets tricky later on. So I pick a sock, okay? Let's suppose it's this one, right? First sock down. And then I have to pick another one, and I want a match. That's what I'm after, okay? So 2 things have changed. Firstly, the sample space has changed, right? I don't have 10 socks anymore, I have 9. Right, so that's reduced, okay? But also, now that I have one of the socks in particular, the favorable outcomes has also changed, right? Now that I've picked one, the second one, I only want this one. This is the only one I'm interested in. Yes? Okay, so far so good. So, the probability of getting a match after that second sock will be 1 times 1 over 9. There you go. Okay, that's 1 over 9. There's the probability. Not so bad, right? What's so hard about this question? Well, let's progress. Now, they give you a whole variety of different mornings. To make it easier to illustrate, I'm just going to think about the next day. 24 hours passed. And now I'm thinking about getting a match the next day, okay? Now keep in mind, this is quite separate to what happened before. I'm not thinking about a match the first and second morning. I would have written first and second morning here, not 2 matches in a row. Just forget about what happened the previous day. I might have got a match, I might not have. I'm just interested in Tuesday, okay? What's the probability of getting a match now, okay? Now, who has an answer that jumps out of them? Any thoughts?
1 over 9.
1 over 9. Okay, 1 over 9. Now, how many people agree with that? You don't have to provide an explanation. I'm just interested in who thinks that's a plausible answer. Hands up straight. I actually want to see. Okay, all right. All right, put your hands down. Everyone who didn't put their hands up just now, I want you to raise your hand for a second. Okay. Now, I want you to keep your hand up if the reason you don't think it's 1 over 9 is because you think it's something else. Do you think it's something else? Or, put your hand down if you're just not sure. But keep your hand up if you think it's something else. It can't be 1 over 9. hands up. Okay, now, anyone who's still got their hands up, because by the way, I have my hand up. I think this is weird. I think this is very strange. My intuition is kicking in and saying, really? Anyone who's got their hand up, why? You can put your hands down now, but why, you guys who did have your hands up, why do you think this seems strange? Why do you disagree?
He has to wash his socks.
He has to wash his socks, okay? So, what difference would that make?
He'll replace it.
So you're, okay, all right, so you're saying this whole scenario, is without replacement. Now, hold on a second. Before we leave off this, who thinks Elian is right? Who agrees this situation is without replacement? Okay, hands down. Who thinks it is with replacement? So, okay, hands down. So I take it a few of you don't know. That's okay. Look at the question again. Look at it carefully. Read it with me. It's all in the language. Is there anything in the question that suggests to you it's going to be with replacement or without? I think Elian's right. I think it's without replacement, and I think the key word is he has 5 different pairs of socks to last the week, which kind of implies by the time he gets to Friday, he's pulling the last 2 socks out of the drawer. Without replacement, I think is correct. Okay. Now hold on. Let's keep pushing on that. If it's without replacement, why is that a problem? Why does without replacement suggest to you that this answer has a flaw in it? Because you would think by the next morning, just like, you know, when we looked at the first sock and then the second sock, the sample space would change, right? And we looked at this yesterday. We looked at the idea of dynamic probability, where when one thing depends on the previous thing, then the probability changes every time. You would think the second morning and the third morning and every subsequent time, probabilities change, right? So I agree. I agree that something seems suspicious with this, okay? Now, the question gives you a clue. Right at the beginning, I didn't read this. It says, this question and the next are best done by retelling the story of the experiment. Now, what happens is you go to the answers, okay? And you look for this and you find, sure enough, a 9 actually is correct. And then they give a bit of an explanation. Now, their explanation goes like this. They say, they follow the advice. They say, retell the story, okay? So what they imagine is, well, you know how I walked through this? I said, okay, the first morning I pick out this one, and then I pick out this one, right? Well, let's retell it. Let's retell it like this, okay? It's Monday morning. I have 10 socks in the drawer, okay? But instead of getting out Monday's socks on Monday morning, I get out Tuesday's socks on Monday morning. Now, what has changed? And the answer is, nothing has changed. I'm still going to be able to pick from 10 socks, it doesn't matter which one I pick first. And then I'm still going to get to pick out one that matches out of the 9 remaining, okay? And so, you know, the second morning actually, and the third, and the fourth, and the fifth, they're all the same. It's all the same. Now, that's the answer the textbook provides, and it's true. It really works, okay? A 9th is the answer, unambiguously as well, no matter how you interpret the question.